Okay, hi friends, it's Samantha. I'm one of your Chem001C SIs. And today we're going to be going over chapter 17. But before we start, my email and my office hour sessions are right here. If you have any questions, please feel free to email me, come to office hour sessions, or even comment down below. We'll try to answer your questions as best we can. But this week we've been going over chapter 17 in Dr. Jang's class. And I just wanted to really do a review of a lot of the important information. So with that, let's get started. With chapter 17, a lot of it, we are going over electrochemical cells, right? And so it's important that we understand our electrodes. And with our electrodes, we have two different kinds, right? We have an anode and a cathode. Well, with the anode and cathode, since we are dealing with redox reactions, which side is which? If you remember from the last video, our anode is the one that oxidizes, and so it's going to have the lower potential. It's going to be a little bit more negative, and the cathode is going to be the side that reduces, and that side is going to be a little bit more positive, right? So if we look at that, one of the formulas he gives you is that an E cell, E, when you put it in notation, you want it to go from your cathode to your anode, right? So essentially, you want it to go from E high to E low. So this is one of the important relations that he wants you to remember and to pick up on. So apart from this, if you move further on, he starts to give you different formulas, right? So he gives you this triangle. I'm going to erase all of this. I hope you guys got all of that. But he gives you, when you know that, he gives you this triangle of essentially formulas, right? It's your cell. At one point, you have delta G. At another, you have your E cell, and then you have work. Well, to connect all of these three, these are all related, right? So he can start off with giving you a value from here, but wants you to calculate to G, but you're only given information from how to get from here to here. Well, you would know how to get from work to delta G, and vice versa. You would also know how to get from E to delta G, or any of the relationships on this triangle, right? Because we know that delta G equals negative NFE. And then E to work is, you can go work equals negative QE, or Q equals NF. So remember, Q is NF, and if Q equals NF, that relates back to the delta G to the negative NFE, right? It's all connected. And then delta G is equivalent to W, right? And we can prove that by looking at these formulas. So if you know this triangle, you'll pretty much know how to do everything else in a math problem for this chapter. As long as you know that, remember, anode oxidizes, cathode reduces. And if you remember from the last video, the trick I told everybody to remember this is that C and R are both not vowels, but A and O are both vowels. So they pair up together in that way, right? So you know that anode oxidizes, cathode reduces. So let's go over a practice problem, right? So if you remember from week 8, worksheet 2, the very last problem I did from the last video, I'm going to break it down a little bit more. So it gave you half reactions plus 2E, gave us these half reactions, right? Now, if we're given just this, do we know what's oxidizing and what's reducing? Oh, I apologize, the video froze. If we're given just this, do we know exactly what's oxidizing, what's reducing? Do we know in this case what our anode or our cathode is? No, right? Because we're also given the standard potentials. So the standard potentials are given as such. And if we remember, we go from E is E high to E low, or E cathode to E anode, right? That gives us our E. Now, if that is the case, and if that is true, we can look at the standard potentials. These are given to us in that problem, right? From these standard potentials, which one is higher, which one's lower, which one is our cathode, which one is our anode? Well, we know that this has to be our cathode because it's higher in value, and this has to be our anode, right? And if that's the case, we can put this into cell notation by going, this is cathode, this is anode. You take that a bit further, and you know that when you're putting it in cell notation, it goes anode, cathode, right? So to put this in cell notation, we would know that it goes zinc to Pb. Now, am I done here? Not quite, right? Because we would need to know that when it's oxidizing, it goes from something without a charge to something with a charge. And then when it's reducing, it goes from something with a charge to something without a charge, right? So this is what it would look like in cell notation. But if you remember, this question asks a little bit more because it asks further, what is the standard Gibbs free energy change for the voltaic cell above? And it gives us our value of F, because remember, delta G equals NFE. Now, I'm going to erase all of this so that we can go through that next part a little bit more clearly. But I hope you got this first part on how to find cell notation. So if you remember from our triangle, right, he has the cell, delta G, E, and work. In this case, these two are the same, right? And then here, it's delta G equals negative NFE. We're trying to find this, right? We know this. Do we know this? Yes, we do, because we know that E, again, goes from E high to E low. So if that's the case, we have negative 0.13 minus negative 0.76. And we can calculate that within our formula, right? So if we do delta G equals minus NF, and then I'm going to put it in. We can find our delta G. Now, F is a constant, and that's going to be given, but what is our negative N? If you remember from the half reactions, we have 2 electrons, so that's going to give us 2 equivalents. So minus 2 times the F times the negative 0.13 minus negative 0.76. Calculate all of that. And like we calculated in the previous video, this is going to give us a negative 121.59 kilojoules. Right? So this is part of what he has taught this week, but it can go even further, right? Because he gave you another triangle of what if your E cell isn't just work, but K. So the relationship here still holds true. It's still delta G equals NFE. But here, your E cell is equal to RT ln-K over NF. Okay? And it's important that you know this because everything that you know from here, you're just going to plug in and calculate for whatever he asks for. That's all I have for today. I hope this was helpful. If you have any questions, please email, drop into office hours, or comment down below.